This looked a lot bigger on eBay, I have to say. But having said that, having looked at the listing for this little sort of almost like a little high bay light for camping, it is the correct size as listed. They don't tell you the battery capacity. I've tested the battery capacity. It's rechargeable, just over 2 amp hour, which isn't too bad. It has these little solar panels. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5 volts. So that'll be charging the lithium cell inside. Although I would rate these at something like 20 milliamps tops. So given that it's a 2000 milliamp hour and this is 20 milliamps, it would take about 100 hours of direct sunlight to actually charge this up fully. So they're kind of just almost like a gimmick. It's available without the solar panels. It's also available without the remote control, but let me demonstrate some of the features. I shall rip the little tab out of this. Right, features. On. That's a useful enough feature. Off. Mode 1 is low. Should I say it's medium, and mode 2 is low. And as you can see, it's pulsed modulated, so you get that striping. And then you've got mode 3, which is stroboscope, and the just SOS. Now, see if you can tell what's wrong with SOS. I'm pointing this away from the camera to avoid causing excessive strobing. Doesn't look quite right, does it? What if I tell you that it's inverted SOS and it's actually blinking out for the dots and dashes instead of actually lighting for them, which is not a very efficient way of doing it. If you use the button on it, you can step through high, medium, low, strobing and SOS, which means that if you're camping and it's like, good night, honey, good night, I'm going to turn the light off, and then it's like, click, 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 stroboscope, da-da-da-da-da-da, and then it's like, da-da-da-da-da-da, before you can actually turn it off. It's got that annoying feature. The thing has a USB output. I did not test that. I suppose I could test it. Where is my little tester? One moment, please. The tester has arrived. Let's zoom down in this. So it doesn't make bold claims. Is that visible? I shall shield it with my hand to kind of make it more visible. Let's turn it up. It's only rated, I think, about 800 milliamp output. I'm not really sure. We'll find out. It's currently at 4.8, 4.9. That's doing okay. 4.9 volt. That's acceptable. It's at 700 milliamp. 4.9. At 4.8, pretty much on the button, it starts dropping off. Let's wind it up a bit more. And it still holds. Yeah, it's dropped down to about 4.6 volts at 1 amp. So not really super mega high output, but still useful. You also have the option of charging it with a USB lead, which is supplied. And it's got that, the charging status thing. Right, tell you what, let's zoom back out again. Bring in my spudger. I know how to open this because I popped the lid on one of the live streams. You pop your spudger in and it just pops out. That's nice. There's the infrared receiver. Oh, that is quite a lot of LEDs. Tell you what, let us pop these little screws out and see what's underneath. Is it going to be an 18650? Is it going to be a rectangular cell? It could fit an 18650 in there. So let's pop the last screw out and then gingerly lift this up. I shall lift it up by the infrared thing. 2 18650s. Oh, they must be pretty much 1 amp hour each. Okay, right, tell you what, it is time to explore this circuit board. It's got a little, maybe that's a charging control chip, and that will be one of those universal, I'm not really sure. Right, tell you what, one moment please, I'm going to explore this. Okay, let's explore. So I've got the two sides of the circuit board. This side is reversed, so it matches component for component down to what's here. So when you see this group of plated through holes, that's this group of plated through holes here. It just makes it easier to trace out. The circuitry is divided into two sections, pretty much right down the middle here. We have a standard power bank chip, something like you'd find on one of these generic little sort of 1 amp output power banks. And it is basically completely separate from this, although the microcontroller they're using does get a signal on 2 lines from the power bank chip, just to tell it when it's charging and discharging. The microcontroller controls the LEDs via this MOSFET down here and this series resistor, which is 0.68 ohm, but it also controls the 4 LEDs and also decodes the infrared receiver, which is on the other circuit board, the actual LED circuit board. So when it's displaying, when you press the button to wake it up and see what charges in these LEDs, as far as I can see, the 5 volts always active over here because it's not connected in any way to these LEDs. That's purely being measured by the microcontroller. So let me bring in the schematic. We start with the power bank chip. Note these scruffy dotted lines. I kind of regretted that, they're ugly, but they're connecting the output from the power bank chip over to the microcontroller just to tell it when it's charging and discharging. It indicates and it does its little light show. I should draw a couple of LED arrows down there. So the USB in for charging has a little filter on it, a 1.5 ohm, 2.2 microfarad, very common. And then it goes to this chip and that then regulates the charging of this lithium cell with a 10 microfarad capacitor across it. When you plug something into the USB out, the chip is one of those ones. It just keeps it topped up to 5 volts as far as I can see. And it uses this little inductor here, 2.2 microhenry, pulses it to actually boost the voltage up onto this capacitor and provide the 5 volt output. The charge and discharge lines that go over to the microcontroller have 2 pull-down resistors. Normally they'd be used to drive LEDs directly. This is the actual data sheet of that chip. It's in Chinese because it's not really aimed at us, it's aimed at manufacturers. But there's the 2 LEDs that would normally be the ones that, in the case of this little power bank, they usually shine through from the back, and it's like, say, red for charging and then it's blue for discharging. That's basically those lines, but they're just being used as signal. The microcontroller, the mystery microcontroller, has a button for selecting the modes. It drives the MOSFET, and it's notable that this is a P-channel MOSFET. It's an A1 SHB, which is the P-channel version of the N-channel A2 SHB. And I wonder if that's why the SOS is completely upside down, because it's almost as if someone wrote this, modified the software that was originally designed to drive an N-channel MOSFET. And if they shuffled the things like full on, for instance, if this was an N-channel MOSFET being driven, when you put it into full intensity mode, you'd actually take the output pin controlling it high, and that would switch the MOSFET on. In the case of the P-channel MOSFET, it's switching to the positive rail, so you actually pull it low to turn it on. So I wonder if they've shuffled things in this chip, in the software, so that, say for instance, full on actually now becomes full off because it's the opposite polarity, and vice versa. And because of the pulse width modulation, say for instance at the low setting, it might have normally been doing this, pulse width modulating the LEDs to make them dimmer. That would actually effectively be on here instead of there. So if that was the low setting, that would become medium setting and vice versa. And that would explain why the SOS mode, instead of flashing on and off, it's actually blinking out. I do think that they've just shuffled the software and it's actually designed for driving an N-channel MOSFET. The 4 LEDs down here, they've just a 1K resistor each, but there's also another 1K resistor coming from the solar panel. And this is where it gets a bit awkward, because it would have been nice if the solar panel had fed over to the USB in so it could regulate the charge to the lithium cell. But in this case, it's just going straight through a diode to the lithium cell. So technically speaking, although the output is very low, at only about, say, 20 milliamps, if you left this thing on a windowsill in bright sunshine, over time, it could potentially overcharge those cells, particularly if they were already fully charged in the first place. It's kind of odd. But the solar panel also has that 1K resistor, so that with the slightest sniff of solar energy, just even room lights, it will also make this LED glow gently just to put on a show. The only other thing is the infrared sensor, which is on the LED circuit board. There's 60 LEDs in this board, apparently. That's quite a lot. It says 60 LED down here. Odd. But the infrared sensor has a little decoupling capacitor mounted locally, just literally between the pins in here. And it's got connect across the battery, and then it signals back to the microcontroller. And that is about it. It's a very strange little thing. The whole Morse code thing is very weird. Like, the person who designed it didn't really know how to tweak the software to get the desired result. But overall, it's hackable in the sense that it's got room for two 18650s. It may be a good idea just disconnecting the solar panel unless you're just going to leave it in a darkish place. But you could theoretically put 2.2 amp hour cells in here, and a pair of them. That would pretty much double the capacity. I'm not sure how hot the panel will get. Technically speaking, it's 0.68 ohms, so technically speaking, fully charged battery 4.2 minus the 3 volts the LEDs 1.3 volts divided by that 0.68 equals 2 amps theoretically at the top, which for the LEDs it would be dissipating about 6 watts in that panel. That's quite high. I don't know if there'll be other losses that will actually reduce that. But there we go. It's a smart enough little light, but it has defects, as they usually do, but it has got the facility that, you could hack it to a degree. And it's got the advantage that because it uses a standard little power bank chip in here, it will always be putting out that 5 volts, which means if you just had low-level ambient lighting, it'd be perfect just to plug them into this without using it as the main light. But there we go. It's an interesting light. It has its defects. It's quite novel defects, but it does have a certain element of hackability. You get options. You can buy it without this solar panel. That might be a good idea. Oh, there's a charging jack that's kind of blocked up. Well, that's the button. Where is the charging jack? The charging jack is under here, that little hole there. It's designed clearly to take a 4.2 volt output charger. It's not something you could just plug a USB output straight into that charging jack. On the circuit board, it pretty much connects across the lithium cell again, so it would have to be the proper charger. But that's it. It was interesting. It was certainly worth taking apart and reverse engineering.